Okay, so when you solve an equation with a radical, your goal is to get rid of the radical. And so I just want to point out a couple properties. If you have the square root of, I don't know, say x plus 2 and you square it, then you get x plus 2. In other words, the square undoes the square root. If you have the cube root of x plus 2 and you raise that to the third power undoes the third root, giving you x plus 2 as well. So what we'll be doing is figuring out which power to raise the equation to in order to get rid of the radicals, but you have to be careful. So if I want to solve the square root of 9 minus x plus 2 equals 7, sorry, let's make that 6, I'm sorry. The square root of 9 minus x plus 2 equals 6, then the idea would be to square both sides to get rid of the square root. But if I were to square the left side the way it is, then that would mean the square root of 9 minus x plus 2 times itself. And if you multiply this out, you'd have to multiply the square roots, then you have to multiply this square root by the 2 by this square root, and then the 2 by the 2. And your square roots are not going to go away. You should verify that if you're not sure. Okay, so instead, what you need to do first is you need to get the radical, the square root by itself, and then you can square both sides. So what we'll do is subtract 2 from both sides. Now, to get rid of the square root, I can square both sides, and I end up with 9 minus 8x equals 16. Subtract the 9, and divide both sides by negative 1, and I get negative 7. Now, you need to check your answer here because you're dealing with a square root. And square root functions have problems. For example, the number underneath here cannot be a negative. The square root of a negative number is not real. So since this has a domain restriction, you need to make sure that negative 7 is actually a solution. So you check it, you get the square root of 9 minus negative 7 plus 2 equals 6. Well, the square root of 9 minus negative 7 is 9 plus 7, square root of 9 plus 7. The square root of 9 plus 7 is square root of 16, which is 4, and 4 plus 2 does equal 6, so that checks out. So x equals negative 7 is the solution. Again, make sure to isolate your radical first, then get rid of it, and make sure to check your answer if you're dealing with an even root because it has domain restrictions. So in this example, I need to try to get the term with the radical by itself. So I will subtract the 3 from both sides. 1 minus 3 is negative 2. Now I will raise both sides to the third power to get rid of the cube root. And so over here I have to cube the 2, which gives me 8. And when I cube the cube root, it goes away and gives me x plus 1. So I have 8 times the quantity x plus 1 equals negative 8. You could distribute the 8 and solve it that way, but I will divide both sides by 8 since it works out very nicely. So you end up with x plus 1 equals negative 1. And subtracting 1 from both sides, x equals negative 2. Here you do not need to check your answer because cube roots do not have any domain restrictions. So odd roots you do not need to check your answers, but even roots you do because even roots have domain restrictions. In this example, the radical is already isolated, so you could square both sides. And when you square the square root, you just get 4x. And when you square negative 4, you get positive 16. Divide by 4 and you get x equals 4. Now this was an even square root, so we need to check our answer. So I've got the square root of 4 times x, which is 4, equals negative 4. So I have the square root of 16 equals negative 4. Well, the square root of 16 is positive 4, so this is not true. So I go back, 4 is not a solution, and the answer to this equation is there is no solution. Now let's go back to the original problem. We're saying that the square root of something equals a negative number. If you recognize that square roots will never give you a negative number, you could immediately say there is no solution. Typically you're not in the right mindset though, so you're going to go ahead and square both sides, and then you have to remember to check your answer, and then you can eliminate it and say there is no solution.